Hello everyone, welcome to Detangle. In this video we'll be solving this question. A uniform rod of mass m is moving with a constant velocity v0 in a perpendicular uniform magnetic field B. So we have a perpendicular uniform magnetic field B which is going into the board. The resistance of the rod is R. So the resistance of this rod is R. The current flowing through the rod R1 and R2 will be. So what will be the current which will be flowing through the rod and these resistances R1 and R2, and R1 is given as 6R, R2 is given as 3R. So we need to figure out what is the current flowing through the rod. Let me consider the current flowing through the rod as I. So the current flowing through the rod as I, and the current flowing through R1, resistor R1 as I1 and R2 as I2. So the current I will be splitting into I1 and I2. First of all, let's ask why there is a current flow. We know that if we have a conductor like this and if it is moving in a magnetic field, let me consider a magnetic field going into the paper like this, into the board like this. We know that since this rod, obviously this is there's a current flow in the rod, so it must be conducting, and there are going to be electrons in this, right, charges in this rod, and since it is moving with some velocity v, we can tell that these charges which are present will experience a force of F is equal to QVB, okay, that is QV cross B. So this is for the positive charge, and for if it is a negative charge, obviously negative QV cross B, it will be in the opposite direction, okay. So as per this, the positive charges will be experiencing a force. Since it is V cross B, when I use the right hand rule, so velocity is like this and it is the magnetic field is going into the board, so like this. So the positive charges will experience a force upward and the negative charges should experience a force downward. So there will be a collection of positive charges at this end and negative charges at this end, and due to that we know that there is a charge separation, hence this will result in a EMF, right. From this point to this point there will be a EMF induced in this rod, and that EMF is called motional EMF, and the expression for motional EMF is given as E is equal to BLV, that is the EMF induced in this rod will be depending on the magnetic field, the length of the conductor and the velocity with which it is moving. Now that we know why there is a current flowing in this, it is because of this EMF induced there will be a current flow since this rod is connected to this circuit. So I can represent this circuit as we have like having a cell here which produces an EMF E, and it is connected to two resistors R1 and R2, and the current flowing in this rod is I, and in this the current splits into I1 and I2. Also they have given that this rod is having some resistance of R, so I will replace this with a resistance R, okay. Now we know that an EMF is induced, and the EMF induced is going to be, in this case it is going to be B, the length of the conductor is going to be L, given as L, and the velocity is given as V0, and an EMF is induced here, but since there is a current flow, we know that the potential between these 2 points are not going to be E, since there is going to be a drop here. So the potential let us represent as V, and this V will be given as the EMF induced minus whatever the drop happens here, that is I into R. And also we know that the potential between these 2 points will be same as potential between these 2 points, also same as these 2 points, which are V. So I'll get expression for I1 and I2 from this. I1 is going to be the potential difference V by R1, and I2 is the potential difference by R2. Now I can simplify this expression. This I can write it as V is equal to EMF induced is BL V naught minus I can write it as I1 plus I2, and instead of I1 and I2 I can substitute this and take common. V will be common, so I'll be getting 1 by R1 plus 1 by R2 into R. And also I know the values of R1 and R2 as 6R and 3R. So if I substitute that here, so this is going to be V is equal to BL V naught minus V. So I'm substituting 6R and 3R here, and if I simplify this, I'll be getting 2R into R, and I can cancel this R and this R, so this will be minus V by 2, and if I get it this side and add it with this V, I'll be getting 3V by 2 is equal to BL V naught, which means V is BL V naught divided by, or 2/3 of BL V naught. So I got the expression for V. So from that I'll get I1 will be V by R1, so that is going to be 2 by 3rd BL V naught divided by, and R1 is 6R, so this is 6R, so I1 will be, this will get cancelled and I'll get BL V naught by 3R, 1 by 3 of this, and I2 will be V by R2, which will be 2 by 3rd BL V naught divided by, and R2 is 3R, so I can substitute a 3R here, so this will be I2, yeah, I can just keep it as it is, and also I will be I1 plus I2, and if I add these two, I'm going to get BLV naught divided by 3R. So from the options, correct option should be this.